7 meter per second downward. Okay, let's do another problem. A bullet traveling at 350 meter per second strikes a telephone pole and penetrates a distance of 12 centimeter before stopping. A. Estimate the average acceleration assuming it to be constant. B. How long did it take the bullet to stop? Right, if you follow everything that we did so far, you can do this problem on your own. A bullet strikes a telephone pole. The instant when it strikes it, it has this velocity, 350 meters per second. That's the initial velocity. And it penetrates into the pole and stops. Is that right? Yes. What is the velocity when it stops? 0. And it travels this distance, 12 centimeters in stopping. You know the displacement. You know the initial velocity. You know the final velocity. You know the displacement. Can you find the acceleration? All right. V0 is 350 meters per second. X equal to 12 centimeter. That is, from V0, its velocity becomes 0 in traveling a distance of 0.12 meter. And Vf equal to 0. We need to find the acceleration. Look at this. Again, the equation that does not contain time. We know Vf, we know V0, we know X. We can find A. So use all those values. 0 equal to 350 squared plus 2A times 0.12. Solve for A from there. 0.24A equal to negative 122,500, or A equal to, look at this acceleration, A equal to negative 5.1 times 10 to the 5 meter per second squared. Why is the acceleration negative? Because the bullet strikes and it is brought to rest. The acceleration is opposite to the velocity. The acceleration is negative. The bullet has a tremendous acceleration, and that is the reason why a bullet can kill, because of the tremendous acceleration it has when it hits. What's the next part? How long did it take the bullet to stop? You see, now that we know the acceleration, we know the initial velocity, we know the final velocity, we can find time using the first equation. Vf equal to V0 plus AT. Is that right? Yes. And we know all these values. Vf is 0, V0 is this, A we just calculated, we can therefore find time. So 0 equal to 350 plus A times T. Can you calculate that time? This is a negative quantity, which when you take it to the left becomes positive. And so T equal to, you can see 350 divided by this number, which gives you a very small number. T equal to 6.9 times 10 to the negative 4 second. Is that right? It's a very small amount of time. That is about 0.69 millisecond. 0.69 millisecond. Is that right? Did you figure out if I get this right? Actually, 6.9 times 10 to the negative 4 is the same as 69 times 10 to the negative 3. And 10 to the negative 3 is a milli. So it is 69 milliseconds, not 0.69. So make that correction there. Okay, let's do another problem. A car traveling at 15 meters per second is brought to a stop at a constant deceleration. A deceleration is a negative acceleration. 100 meters from where the brakes are applied. What is the time taken by the car to stop? How far has the car moved when its speed has been reduced to 10 meters per second? Alright, what do we have? We got V0 is 15 meters per second, is brought to a stop, means Vf equal to 0. At a constant deceleration means the acceleration is negative. 100 meters from where the brakes are applied. That means velocity from 15 meters per second becomes 0 during a displacement of 100 meters. X equal to 100 meters. What is the time taken by the car to stop? Well, here's a little problem. We have V0, Vf and X. Well, is there an equation that connects V0, Vf, X and the time? We need the time. There is no equation that contains all these three. And therefore, what you need to do is, if you know V0, Vf and X, we can calculate the acceleration. So we will do that first. First we obtain the acceleration A using what equation? The one that doesn't contain the time. Vf squared equal to V0 squared plus 2ax. That is 0 equal to 15 squared plus 2a times 100. And solve for A from there. You get A equal to negative 1.125 meter per second squared. Well, once you have the acceleration, we can now use these values of V0 and Vf and this A to find your time using what equation? Equation number 1. Vf equal to V0 plus AT. We have Vf equal to 0, 0 equal to 15, plus A equal to negative 1.125 times t, and solve for time from there. That gives you t equal to 13.3 seconds. You can see that's a two-step problem. You got to use the given data to find acceleration and then use the acceleration to find the time. Alright, what's the next? How far has the car moved when its speed has been reduced to 10 meters per second? Well, this time, this is your final velocity. You see, you must now know the acceleration we know, the initial velocity we know, the final velocity here is given to be 10 meters per second. We need to find what? How far has the car moved? Find x. Alright, so for that part, V0 equal to 10 meters per second. Now, this is not what we need. We need Vf equal to 10 meters per second. This is the acceleration. We need to find our x. When the speed is reduced to 10 meters per second, we have Vf equal to 10 meters per second. And now we use the equation. Which equation? We are looking for x. Is that right? Yes. Vf squared equal to V0 squared plus 2ax. Vf you know, V0 you know, acceleration we know, and therefore you can find your x. Alright, I'm going to leave it for you. I will just show you the steps, simplify this, and solve for x. Alright, that gives you x equal to 55.5 meter. Now you need to do all these problems on your own, okay? Alright, let's do one more problem. We have now done a number of representative problems using equations of motion. And in order to be very familiar with it, you got to go back and do all the homework. You see, only by practice you become perfect. And if you need to really enjoy physics, you need to understand these concepts. Now, very often I notice that students do poorly in conceptual questions. You need to understand the basic underlying factors in these simple processes. You see, the nature obeys very simple rules. And if you understand those very simple rules, you can understand nature in a very intimate way. And once you understand, you can enjoy nature. And solving problems using the phenomenon in nature becomes a joy. Alright? So, solve these problems in the homework and let me know if I can help you with more information or anything else. Okay, I will see you for the next lesson, lesson 3, later on.